Alright everybody, hello and welcome to day 16 homework tutorial. If you're looking at this, then hopefully this is giving you that extra little boost that you need. What we're going to do today is we're going to talk a little bit about how to look at this weather station model that we've seen before, but now we're going to talk about the numbers over here, specifically the number for barometric pressure. So as you read about, the barometric pressure is coded, meaning that the actual air pressure is not 146, it's something else. And so what we're going to do is, let's just quickly review. 43 degrees, if you notice, is based on our reference table, as we've seen before a million times. Down here at the bottom of the reference table, it tells us that the top left is going to be temperature. So 43 degrees is our temp in Fahrenheit. If I need to convert to Celsius, here's an easy trick that you can use. There's a reference table T here that's on page 13. Let me do that a little better for you. Reference table T that's on page 13. It shows the temperature. And you can go from Fahrenheit to Celsius and Celsius back to Fahrenheit by looking at the numbers here. So first thing I want to do is find 43 degrees Fahrenheit on this side, and it's going to be somewhere around here. And then to find Celsius, I just go straight across and read it. So 43 degrees Fahrenheit, if I look very carefully, and hopefully I can mark this correctly, 43 degrees Fahrenheit is about, I don't know, 6, 7, 8 degrees Celsius, and that's how we do that. We can do the same thing with this temperature here. We know that that is on the bottom left, and if we look here, the bottom left is 27. That matches with the dew point. So 40 degrees is a dew point. And again, we can do the same thing here, where it's going to be very close to where we just did it. 40 degrees is probably going to be about 6 or 5 degrees Celsius. And then 0.6, you might be wondering what that is. If again, we look at the bottom right of the reference table, it tells us the precipitation, how much rain fell in the last 6 hours. I'm going to abbreviate that precip, and then we're good to go with that. What we're going to figure out next is what this barometric pressure actually is. Now, the funny thing about this barometric pressure is that all of the barometric pressures that we need to find on Earth usually are on one of our reference tables. And I'm going to show you now where exactly to look for the pressure. So if you look at this reference table here, that's reference table U, this has the pressure here in millibars, and that's what normally we see on a weather station model. The pressure is usually written in millibars in some kind of abbreviated form. I'm just going to go ahead and copy one of these numbers down, because these are the usual pressures. It usually starts from around 960 to 1040 millibars. That's the normal pressure on Earth's surface. You normally don't go below 960 unless you're in some kind of strange, crazy storm or even a tornado. And then you don't go higher than 1040 on Earth's surface. So the big idea behind the air pressure is going to be figuring out what the code is. So to figure out the code, there are two things. One, they wanted to save time and space when they did these weather map symbols. And so what they wanted to do with the weather station models is every air pressure on Earth usually starts with 1,000 or 900. So what they did to save a little space is they got rid of the 1,000 or the 900, and they just kept the last 3 digits. So if you look at it, the decoded, the real air pressure is 1023.3. But the code is 233. It's the last 3 digits. Okay, same here. The last 3 digits here for 978.6 would be 786. And so when writing the code, that's how we do it. I'm going to do 2 more, and then I'd like you to do one. Again, we're going to get rid of the 9 or the 10. And we're going to keep the last 3. The last 3 digits are 891. And so again, the idea is if we want to represent 989.1 millibars of pressure, on a weather station model, when we draw our weather station model, no matter what it looks like, if it's very windy or not very windy, or super cloudy or not very cloudy, the barometric pressure goes in the top right, and it's the code, not the real pressure that goes there. 891. Okay. Let's go ahead next, and we'll talk about how to do the next bit. The next bit is a little more difficult. You need to use reference table U to figure out the air pressures if you want to go from the coded ones to the uncoded one. I'm going to go ahead and just highlight this. The end result has to be between 960 and 1040. So whatever number we come up with when we decode it, it has to be one of these two. The way to do it is like this. Take your code, and since when we made our code up here, we dropped a 9 or a 10, we're going to come up with two possibilities. One is add a 9 in the front, and then 2, 5, 4, and then a decimal point. I'm just make that a little neater for you. 2, 5, 4. We add a decimal point there. So one of the possibilities is 925.4. And the other possibility, if you noticed up here, because we could also get rid of a 10 to keep the last three digits, is 10254. Put a decimal point back. And now it could be 1025.4. To figure out which one it actually is, we need to go ahead and take a look at, again, this reference table here, reference table U, and see which of these numbers, 925 or 1025, is actually on this for the air pressure. If we look, the lowest number on here is 960. So 925 does not fit, and the code for 254 is actually 1025.4 millibars. Again, I know that because 1025 is between 1040 and 960. I'll do one more, and then I hope this is good enough practice for you to go ahead and finish. Same thing here with 899. I have two options. I can add a 9 in front and then just copy the rest of the numbers, remembering to put my decimal point. So it could be 989.9 millibars, or it can be 1089.9. I add a 10 in front. Again, let me see if I can get that a little neater. To figure out which one actually fits, again, I refer to this reference table one more time, and I ask myself, is 989 between 1040 and 960? And yes, it is. This is higher than 960, but less than 1040. So this actually is the correct number. If I want to check the other one, 1089 is much higher than 1040 up here. This is the highest that I should be able to go. So since it's higher than 1040, I know that this is the wrong air pressure. Okay? So again, the big thing to take away from this is when you're doing these air pressures, you need to make sure that you go ahead and add a 9 or a 10 in front of the number. Once you do that, put a decimal point so that you have one decimal point place. And then you ask yourself which one of these numbers actually is in this range from 1040 at the top to 968 at the bottom. Okay? And that's the big idea.